Hey folks, so today we're going to talk about multiplying and dividing rational expressions. So just like multiplying and dividing fractions is somewhat easier than multiplying and dividing rational expressions, the same thing is true here. Adding and subtracting of these things is going to be a bit more labor intensive, but it follows the exact same rules that the fractions you know and love follow, so it should be new information, but not entirely new. It has a basis in something which you have seen before. So let's go take a look at it. Well, the first thing we need to talk about with adding and subtracting rational expressions is a bit of vocabulary. And it's something you have definitely seen before, the lowest common denominator, the LCD. And it's the product of all the factors of one or both of the denominators. And now the important thing, as we've been seeing with factoring, is the product. We know that is going to be incredibly important. And here are our steps. If you want to pause this video and write in those steps, it's a really good idea. Find the LCD of the fractions, write each fraction's equivalent fraction with the denominator equal to the LCD. Add or subtract, remember, that's just the numerators. Whenever we add or subtract, we're not changing the denominators. Simplify, in this step we're just doing the numerators. And then we're going to reduce to the lowest term. That last step is going to involve cancellation. Now with this, our goal is to split the fraction apart as much as humanly possible. So the only time you're ever going to be doing anything like distribution is step 4, when you're combining the numerators together. Every other time, you're focusing on making the fraction split up into its component factors. So it's going to look like it's getting larger, because we're going to turn something like a trinomial into two binomials, or we're going to expand the factors out, and that's okay, but don't be tempted to do distribution in anything besides step 4. Now to find the LCD, you just factor out every single denominator and then make sure the LCD has a factor from every denominator. So for instance, if we had one denominator that was 4x, we had another denominator that was 5x squared, well the LCD would have to have the 4, it would have to have the 5, because those are two separate factors. We got our 4, we got our 5. Now, it has to have an x squared. Now, the reason it has to have an x squared instead of just an x is because x squared includes x already. So, you don't have to put the x by itself again, it's already included in the x squared. So, then you would just highlight that too. You could clearly simplify this LCD if you wanted to by saying it's 20x squared. I'm going to push you today to not do that simply because our goal is to, at the last step, cancel things out, and I don't want you to have to combine things together to later cancel them out. Now, while it is true that the LCD is going to be the easiest, there is an alternate method. So if you're struggling with the LCD and you're struggling how to find it, you can totally do this one. You can just turn every denominator into the same thing, the same denominator, by multiplying every denominator by every other denominator. Okay? It won't be the lowest denominator, but it will make more factoring for us later. And to give you an example of what that would look like, it would be this. So, suppose I had this, and instead of trying to find my LCD, I decided I was just going to go ahead and multiply the first expression by the second one. Well, I multiply this one by 5x squared over 5x squared. Suppose I didn't need the parentheses there. And I'm going to multiply this one by 4x by 4x. So I multiplied the second fraction by the first denominator and the first fraction by the second denominator. Okay, you can do that. It's going to make a larger denominator for us, but it is definitely an option. Let's take a look at some examples. Cool, so these are simple examples. We're still going to follow the steps. We're going to work our way up to more complicated examples. It's going to be great. So let's take a look at problem 1. Find the LCD of the fractions. Well, my LCD here is going to include the 5 from the first one. I have that as a factor, that's a second factor, that's a third factor. So that means my LCD has to include all of them. X to the third. So I'm going to multiply my fractions by this. Well, actually, I'm not going to multiply my fractions by this. I just need to make my denominators all look like that. So I have my 3 times 5x cubed. The only thing that's missing from my LCD in this first fraction is the 2. So I'm going to multiply this by 2 over 2. Plus my 1 over 2. Now this is missing a bit more of my LCD. It only has the 2, which means it's missing the 5 and the x cubed. So I'm going to multiply this by 5x cubed over 5x cubed. Remember, just like everything else, if you're multiplying, you're trying to keep it balanced. Here I'm multiplying by 2 over 2, which is equal to 1, and 5x to the third over 5x to the third, which is also equal to 1. So that way we're keeping everything balanced. And in this way, we have found the LCD of the fractions, and we're in step 2. So I can just combine everything together. I'm going to say 6 over 5 times 2 times x to the third plus 5x to the third over 5 times 2 times x to the third. So I've written each fraction as an equivalent fraction with the denominator equal to the LCD. I'm done with step 2. We're going to add or subtract now. And remember, this is just the numerators. So my denominator is going to stay 5 times 2 times x to the third. And now my numerator is just 6 plus 5x to the third. So I've added or subtracted. Simplify, remember just the numerators. Here I can't do any simplification. The 6 doesn't have a variable, and the 6 and the 5 don't share any factors. So I can't do anything here. And just reduce to lowest terms. Well, there I'm going to just combine everything together. So 6 plus 5x over, and here I'm going to say 10x to the third. And that would be my final answer. You can always check this using Desmos by plugging in the first expression and the last, and the graph should be overlapping completely. Let's take a look at another example. If you want to pause and write this one in, you should do it. Second example time. We're still going to do the exact same thing here, but this example definitely looks different because this second does not have a denominator. It's not a fraction. And I specifically wanted to do this one to show you that's not a big deal, because we know that we can just write everything as a fraction by putting it over 1. Well, now I need my LCD, and my LCD here is just going to be the 4x squared times the 1, but we know if we multiply everything by 1, it doesn't matter. So that's my LCD. It has the 4, it has the x squared, and it implicitly has the 1, because 1 is a factor of 4. So I found the LCD. Now, time to write each fraction with the LCD as my denominator. Well, the first one doesn't have to change. It's already like it. We're good to go. Second one does have to change. 4x squared, 4x squared. And you're going to see why in a second, but we might not want to combine those things together. Cool, so I wrote each fraction as the LCD. Add or subtract, remember it's just the numerators. So I'm going to have 5 minus 4 times 4x squared over 4x squared. You cannot cancel those 4x squareds. You cannot do it. So here we can't actually simplify anything. We can just reduce it to lowest terms. I promise there will be times when we can simplify. This is not these examples. So reduce to lowest terms, that's 16x squared over 4x squared. You can totally check this using Desmos. This is fully simplified. We can't do anything about it. We can most definitely not cancel those x squareds out because the 16x squared is joined to the 5 by subtraction. So let's take a look at some ones that are a bit different. We're going to go a bit faster here because I think you're getting the hang of it. So the LCD of this, well, they both have a 2 in them, so my LCD has to have a 2. I have an x, so my LCD has to have an x. I've underlined all the factors. I'm good to go. So to make the first one into the LCD, I have to multiply it by x over x. Second one's already the LCD, so we're good to go. Cool, so I'm going to have x over 2x plus 5 over 2x. I'm going to combine them together, because I've done step 1 and step 2, over 2x. So I've done that. Simplify just the numerators. Well, I can't simplify that anymore. And reduce to lowest terms. It's already in lowest terms. I'm good. That one's completely done. You can definitely check it using Desmos. So, second one, LCD. Well, I have a 3 here. I have an x in both of them. I have an 8. So I'm going to sneak the 8 in here. Honestly, if you want, you can combine this together into 24x. I'm going to keep it separate just in case some things can cancel out. But if you want to, that's fine. So we did our first thing, we found the LCD. Now second, we want to write each fraction with the LCD in the denominator. Well, that just means that I'm going to need 2 times 3x. It's going to be times 8, because that's the only thing missing from this denominator. Plus 5 times 8x times 3. Again, that's the only thing missing from the denominator. Again, we're multiplying numerator and denominator. Cool. I'm going to just combine this together. I'm going to move this down a little bit here, folks. So I'm going to have 16 over, let's just do it, 24x plus 15 over 24x. Cool, so I wrote that. I'm going to add or subtract. Here I'm adding, so that's going to be 31 over 24x. So I did simplify my numerators by adding the 16 and the 15. And then reduce to lowest terms. Well, 31 is prime. 24 doesn't share any factors with it besides 1, so that's our final answer. Cool. So you're probably wondering at this point, why are we doing problems that look like this? We haven't had to factor polynomials in a while. Well, I'm glad you asked, students, because we're going to do them like this now. So I'm going to get this out of the way a little bit up here. Go away. Go. Shoot. And we're going to do these problems. Now, these clearly look a lot different than the ones we just did. However, same principles are going to apply. I can't factor out the denominator of this first one, so that's just going to stay as is, and that's okay. So I'm going to have 3x plus 2 over x minus 7. I can most definitely factor this one out, and that's going to be very, very helpful. That's going to be, let me just fill the rest in here. Factored by factors and sums, I want numbers that are going to multiply up to negative 14 and add to negative 5. Well, that's going to be x minus 7 and x plus 2. Now let's look for our LCD. Well, they both have an x minus 7. So our LCD is going to include x minus 7. There's also this x minus 2. Excuse me, x plus 2, I misspoke. So that's also going to be part of our LCD. We can see that the second expression already has the LCD in its denominator, so we won't have to change that one. The first one is going to need the x plus 2. Well, let's add it in. So we're still going to have 3x plus 2. We're still going to have x minus 7. And it's just going to have x plus 2 over x plus 2. Second one is just going to remain the same because it already had the LCD as the denominator. So now they have the LCD as our denominator, I'm going to just combine them together. So I'm going to write one fraction. It's going to have the x minus 7 and the x plus 2. It's going to have this part all thrown together. And just to be really clear, this is the entire 3x plus 2 times the entire x plus 2. So we're going to need to use box method for that, or FOIL. And that's going to give us 3x squared plus 6x plus 2x plus 4, all minus the 2x. So now we're up to simplifying the numerator, and here it's clearly a bit more complicated than it has been. So we're still going to have 3x squared. We got a 6x plus a 2x minus a 2x, which is going to be plus 6x plus 4. That's going to be all over x minus 7 and x plus 2. Now, there's nothing else we can do to factor this out. As unsatisfying as that answer looks, that is our final answer. There's no GCF in the numerator. Even if I were to break that up by grouping, there's no factors of the 3 times 4, so the 12. That would add up to 6. So we're just going to leave it. We're done. Real quickly, check your work using Desmos. Again, it's always nice to walk away from this knowing that you're right. So I'm going to do 3x plus 2 over x minus 7 minus, put another fraction in, 2x, x squared minus 5x minus 14. And this should give us the same graph as our simplified form. If it does, we're good to go. If it doesn't, well, something went wrong. And we're right, we're good to go. Same graph, if I take out the blue, the red is there in the exact same place. Always a really helpful thing to do. It's a bit of a pain in the butt to type these things in. However, it's nice to know you're right before you walk away from the question. This one, again, you might be tempted to say, well, we don't have a fraction here. I do have a fraction here, it's just over 1. So, my LCD. I have one factor of x minus 6. I have another factor of 1. But again, 1 times anything is just the same thing I started with. So I'm not going to multiply it by the x minus 6, I'm just going to leave it. So find the LCD. Write each fraction's equivalent fraction. Cool, the first one already has the LCD as its denominator. So I'm not going to worry about that. Second one, I'm going to multiply by x minus 6 over x minus 6. And then I'm just going to add or subtract, so it's going to be 7 plus 5 times x minus 6 all over x minus 6. Now, those x minus 6's cannot cancel out. The 1 in the numerator is not just multiplying everything else in the numerator, it is being added to the 7 as well. We can't cancel. We can try to simplify our numerator, though. Now we're in step 4, so it's going to be 7 plus, distribute this 5, 5x minus 30 over x minus 6. And then we can just combine everything here together. We're going to get 5x minus 23 over x minus 6. And we can't simplify that anymore, so we're just going to leave it. So, last one. You might notice that these look very, very similar. They're not exactly the same, though. Reason being, that first one in yellow has a negative x, the second one in green has a positive x. They cannot be the same factor. Now, while you can do what I'm about to do with either of the denominators, I'm going to do it with the yellow one because I don't like that negative x. I like my leading coefficients to be positive. So I'm going to change this yellow one to be 1 over, I'm going to take a negative 1 out, so it'll be a negative 9 plus x. I should extend that. My second one's going to remain unchanged. Now you might still be saying, but wait a second, these are not the same thing. They're still not the same. One has a negative 9 plus x, the other has an x minus 9, but they are. I can rearrange these terms to make them look exactly like that. So I can have 1 over negative 1. I'm going to put the positive x first, the negative 9 second, plus 5 over x minus 9. And now they look exactly the same. That's a pretty important step. Cool. From here on out, I'm just going to find the LCD. Both of these share an x minus 9. The only thing missing is a negative 1, so I'm just going to multiply a negative 1 on both sides over here. So the first one's just going to be negative 1, x minus 9, plus negative 5x times negative 1, x minus 9. Cool. Combine it together, so we're going to have 1 minus 5x over negative 1, x minus 9. I can't combine or simplify anything here. Nothing cancels out in my numerator or my denominator, so I'm just going to throw it all together. And you can leave it like this if you want, or you can write in standard form by putting the variable first and just distributing that -1 in. It's your call. Either one of these I would accept, and I hope Delta Math does as well. All right, we've seen a bunch of those examples now. You've seen how to check it in Desmos. You know what's going on. You've seen some common pitfalls where if you're doing the Delta Math and you're like, I have no idea what this looks like, you can go back and look at it in the video. Also, you've taken wonderful notes with it, so you can constantly refer back to your notebook. That's a very important step here, folks. So, give those Delta Math problems a try. Then you're going to do the summary, and last but not least, the reading survey. All right? We are very close to the end of our unit here, so keep an eye out for announcements on your next unit exam. Have a great day, folks, and stay safe.